All right, we're on the third video for the Unit 5 assignment, Math 10C. Identify which one of the following is a linear function. So this is a function on the graph that is drawn as a straight line. Whatever that straight line is, as long as it's not a vertical line, it's a linear function. So we could go through here by some various tests and say, okay, if we've got squareds in there, that's probably not linear. If we have a series of points, that's probably not linear. Another squared, probably not linear. Which leaves us with really only two things to test. This by itself is just complete garbage, but whatever. Or we could do something else. We could plot them. So if we plot these graphs, our first one, y equals pi x, which is the same as c equals pi d, but just written in a way a graph will understand it, does look like a line. That's our winner. That's the linear function. But if we show the other ones, so if we show x squared plus y squared equals 16, that's a graph of a circle. If we show the series of points that they gave us, they show up as these dots here, negative 1, 1, 2, or sorry, 1, 1, 2, 4, 3, 9. 4, 16 is going to be up here somewhere. Where are you? There you are. And they don't form a nice line. But more importantly, they're points. They're not a line. This last one, x squared, just isn't plottable as it is. I think the best way to interpret that one would be as a graph of y equals x squared, which is not a line. It's a parabola. And the other options they gave us were y equals x squared minus 4. That x squared makes this a quadratic. Well, it's not quite a quadratic, but we get a parabola. And our last one, which was a potential, I'm going to just hide everything else that's not a line here. 2x plus 6x plus 7 equals 10. That gets us a straight line, a straight vertical line. So straight line sounds linear, but a straight vertical line means it's not a function. So not just a line, but also a function. This one is both. This one is a line, but not a function. This one was a parabola. This one was a series of points. This one was a circle. So our best one was A. Next, identify which of the following is not a function. These are the same things as we had on our last question, just which one's not a function. And functions are the ones that cannot have, if we have our axis, we cannot have at one x value a y there and a y there. We could have a y there and a y there, but if they line up perfectly with each other along a vertical line, that means we are not dealing with something called a function. So if we look at the graph that we just had, the one that made the vertical line was this one, 2x plus 6x plus 7 equals 0. That made the vertical line. And so the vertical line here, E, is not a function. But remember, there was also a circle. So a circle is not a function, right? I'll go back to the graph. A circle, this one here, if we drew a vertical line through any point inside the circle, we would hit the circle twice. That's not a function either. So for this question, not a function. B is not a function, and E is not a function. So B and E are both not functions, and both of these would be marked right if you chose it. The other ones all are. Except for this, which I don't know what to deal with. I'm not sure what anybody was thinking when they wrote that down. This is just nonsense. We'll do one more page here before I go to the next video. Here we've got another graph, a graph of temperature versus freezing point of salt water. And this asks you, questions over here, what is the dependent variable? The dependent variable always shows up on our y-axis, not the x-axis. So we just look at the label of the y-axis. It's temperature. The temperature is what changes. If we take a look at the freezing point of water, which really we're looking at how many grams of salt we add per kilogram of water. What changes is the point at which it freezes. So the temperature is our dependent variable. The freezing point of water changes with the concentration of salt is a good description of this graph, but it's not the dependent variable. Salt water is the thing you're measuring, but it's not the dependent variable. Salinity in grams of salt per kilogram of water, that's the independent variable. That's the one you're changing. You're adding more salt, seeing the freezing point. Adding more salt, seeing the freezing point. So the independent variable would be E. But the dependent variable is the temperature, what changes as a result. Question 15, for the function f of x equals 2x minus 8, what's the value of f of 2 minus f of 4? So for f of 2, we just plug 2 in. 2 times 2 minus 8. 4 minus 8 is negative 8. And for f of 4, we do the same thing. We plug 4 in. So that's 2 times 4 minus 8. 2 times 4 is 8, and 8 minus 8 is 0. So this is saying f of 2 minus f of 4. F of 2 was negative 8. And if we take away f of 4 was 0. Negative 8 minus nothing stays as negative 8. That's not true. What did I do wrong here? 4 minus 8 isn't negative 8. It's negative 4. Negative 4. Negative 4 minus nothing is negative 4. I should go back and fix this video, but I won't. You can deal with it. You've seen me make a mistake before. So in this case, I made a mistake with subtraction. Classic. Next, we have the function c of f equals 5/9 f minus 32. It's what we use to convert Fahrenheit temperatures to Celsius temperatures. Determine the value of f, so the temperature in Fahrenheit, when the Celsius temperature, c of f, is negative 21. So negative 21 Celsius is pretty cold. 70 degrees Fahrenheit is like room temperature. Negative 70 degrees Fahrenheit is really super cold. These two, okay, maybe. If you have experience with both of these, you could go right away to saying like negative 21 Celsius is like negative 6 Fahrenheit. That's the only one that you probably would guess. But some of us don't have experience with both of those scales. In an ideal world, we would all just be using Celsius all the time. So it says find the value of f when c of f is negative 21. c of f is negative 21. That's equal to 5/9 f minus 32. I want to solve for f. So f minus 32 times 5/9, I'm going to divide both sides by 5/9. That means that this 5/9 and that 5/9 cancel. I'm just going to leave this as negative 21 over 5/9 for now. It's a mess, but that's okay. Is equal to f minus 32. I want f by itself, so I need to add 32 to both sides. So negative 22 over 5/9 plus 32 would be equal to f. Now, if I take negative 21 and I divide it by 5/9, I find it's negative 37 and 4/5. It's not any prettier. 37, I'll draw a better 7 and 4/5. Plus 32 is equal to my temperature in F. And if I add 32 to that, well, 37 and 32 is about 5 away from each other. So we're at negative 5 and 4/5. That's my temperature in Fahrenheit. So 5 and 4/5 as a decimal, that's negative 5.8. I find that a lot of people do better with rounding of decimals than fractions. So negative 5.8 Fahrenheit. The closest value here, so to the nearest degree, the closest value here is 6, negative 6. Last one on this page. For the function f of x equals 2x minus 8, what's the value of f of 2 minus f of 10? This is a lot like a question we had a minute ago. We want to find both of those values. So f of 2 means I take 2 times 2 2 minus 8. That became a 2. 2 times 2 is 4, and 4 minus 8 is not minus 8. It's minus 4. I made that mistake once. I won't make it again today. And f of 10. If I put 10 in where the x is, that's 2 times 10 minus 8. That's 20 minus 8. And 20 minus 8 is 12. So this value here is 12. And this value here was negative 4. And negative 4 minus 12 is going to be negative 16. So we would type in negative 16 into the box. Okay, I'll stop here and make the last video.